Yeah, you have it. Well, then we have the vaccine producer. Anyone made the vaccine producer? Okay, so the result is 22%. And the stock market? Let's go. That's the line, 22%. Okay, so let's first maybe do one example. And let's use the car manufacturer here. I hope it's okay if I don't write the full formula, just plug in the numbers immediately. So let me first write down extensively the whole thing. So that's 20% for the first scenario. And then in parentheses, I have my return minus 25%. I now subtract my expected return of 9%. And then I square this thing. And then I add the next term, 50% probability for the next scenario, and my return is 10%. My expected return is 9%. And then for the final scenario, I have 30% probability, and then my differences are 30% minus 9 squared. So if you look at the parentheses here, we have a negative number, we have a small positive number, and we have a large positive number. But they're all going to be squared. I'll write down the results for the parentheses to see kind of where kind of the value comes from. So it's 20% multiplied with, and then in parentheses I would have 11.56% squared. So remember there are two percentages now. Plus 50% times, and here we have 0.01% squared, plus 30% times 4.41% squared. So if you look at the magnitudes of the numbers, you see that this number here is basically dominating the whole result, right? 11.56. The next big one is 4.4, so this one is more than twice as large. And the one in the middle, where you're very close to the expected value, is negligible, right? So it's 0. Right? So what you see is that the values which are far away from the expected value create large outcomes for the variance. Right? So that's the variance that I wrote down here. Right? So this here, the negative deviation, so minus 25 minus 9 gives us minus 34. Right? So the deviation is 34. Here the deviation is only 21. Right? So the deviation is twice as large here. And in percentages, it's almost 3 times as large in the final result. Good. So at the end, just multiply through, and then the final result, but don't forget the square root, and then you get 19.1%. So let's look at the results and whether they make sense. Let me first see, are there any questions regarding the computation? So then let's check whether these numbers make sense. So the lowest one is the supermarket. Right? So that was something that we predicted. The second lowest is actually the stock market with 9.2%. And then comes two things that are a little bit odd. If you compare our gasoline car producer and the electric car producer, right, we've argued that the electric car manufacturer is strictly or better or the same in any scenario. So here it's the same, but here it's better basically. But what happens to my risk measure? My risk measure says it's larger risk. Right? So the reason for that is that the variance measures the distance to the expected value and doesn't care whether it's a positive or a negative distance. Right? So it will always measure variation independent of when this is basically going to happen. Right? And here we have a positive case. Right? It's strictly better, it's 25% more, but our risk measure picks this up as a higher risk. Right? So variances measure positive and negative deviations similarly. And then we have two securities which I would say are kind of almost equally risky, but if you look at the profiles, they're absolutely different, right? make the comparison. Here I can lose 25%. My maximum loss here is 5%. However, this loss has a higher probability of 80%. This is a low probability. But probabilities are incorporated in the formula. And then we have these extreme cases, which are also different scenarios, right? Here I get 50% and I get the 30% here. Right? And again, here it's a large positive outlier, so 50% minus 6% squared. So most of this 22% will actually come from this scenario, right? From where you get the highest return. Right? And in the final result, our volatility now says the vaccine producer is more risky. But I would argue it's not so straightforward because these are fundamentally different securities that we cannot compare easily. Right? So some of our intuitions are in there, right? The variation part is in there. The general ranking that the supermarket is the lowest, that's in there. We've incorporated the probabilities, so that should be in there. But the big problem is that negative and positive differences are treated the same way. And the larger this difference is, so here, this would be a number that I call an outlier, so it's far away. The outliers have, because you square the difference, have a very large weight in the computation. Right? So it's a good first risk measure, but it's a little bit problematic for those two reasons. I've written down here the points that I just made. And I think this is a good opportunity to do a short break now, before we move on to the next risk measure. So let's be back at 10:15. But our risk measure picks this up as a higher risk. Right? So variances measure positive and negative deviations similarly. And then we have two securities which I would say are kind of almost equally risky, but if you look at the profiles, they're absolutely different, right? Make the comparison. Here I can lose 25%. My maximum loss here is 5%. However, this loss has a higher probability of 80%. This is a low probability. But probabilities are incorporated in the formula. And then we have these extreme cases, which are also different scenarios, right? Here I get 50% and I get the 30% here. Right? And again, here it's a large positive outlier, so 50% minus 6% squared. So most of this 22% will actually come from this scenario, right? From where you get the highest return. Right? And in the final result, our volatility now says the vaccine producer is more risky. But I would argue it's not so straightforward because these are fundamentally different securities that we cannot compare easily. Right? So some of our intuitions are in there, right? The variation part is in there. The general ranking that the supermarket is the lowest, that's in there. We've incorporated the probabilities, so that should be in there. But the big problem is that negative and positive differences are treated the same way. And the larger this difference is, so here, this would be a number that I call an outlier, so it's far away. The outliers have, because you square the difference, have a very large weight in the computation. Right? So it's a good first risk measure, but it's a little bit problematic for those two reasons. I've written down here the points that I just made. And I think this is a good opportunity to do a short break now, before we move on to the next risk measure. So let's be back at 10:15. So we've talked about whether the security or asset is giving you payoffs in good or bad scenarios. Right? So let's look for those securities in here. So we have two kind of extreme securities, one that gave you money in good states and one that gave you in bad states. So which type of security would you associate with these two extreme kind of examples?
I think I would go with bonds.
So vaccine producers example for which type?
Probably bond and
Which one? Do you have to pick one? Good or bad state? Bad, exactly, right? So this here has the property of an insurance against the pandemic, basically. right? So it gives you basically no payoff or a little bit of a loss in states where the vaccine is not relevant. And here you make a big profit, right? It gives you an insurance against this crisis scenario. So, as a kind of financial argument, like if you were a restaurant producer or a provider or an operator, or you're organizing music concerts, which are all kind of shut down due to lockdown, it would have been very beneficial for you as a risk management device to have such a security in your portfolio. Right? Unfortunately, you need to buy that before the thing happens, right? You can't do it in hindsight. Right? So that would be something that we would associate with a bad scenario. How about the other opposite extreme? So something that gives us a high return in a good scenario.
Probably electric car.
Yes, the electric car manufacturer has something, I may have chosen the names like this, so it has a very negative return in the crisis and a very strong positive return in the good scenario. So looking at these scenarios, we can figure out what good and bad is given the names that I've chosen. But how do we do that in real life? Right? Because we can't observe, are we currently in a good scenario or bad scenario? You can have an opinion about this, but if we want to calculate something, how do we measure good or bad? And there is a very simple solution, and that is we just look at what the stock market does. So the stock market here is now our indicator, our benchmark for what good or bad is. If the stock market overall does really badly, we call it a bad state, a crisis. And if the stock market is doing well, we call it a growth scenario, a good state. That's our benchmark. We don't know whether it's good or bad, but we use this here as an indicator. The advantage of using the stock market as the indicator, not something like GDP growth or inflation or unemployment rates, is that you have usually the stock market data on the same frequency as you have the stocks themselves, right? And usually that's very important if you want to kind of look at for the numbers that we're going to compute. So if you have a number like GDP growth, which you observe once a month, if your share price sort of daily, it will be difficult to kind of put these two data pieces together, right? So of course you can do monthly returns, but unfortunately these kind of very slow moving things like GDP or unemployment rate, inflation, they don't really work as good as the stock market. And so it's definitely not a perfect choice, but that's what we're going with, right? So we choose the stock market as our indicator. And later on, it actually needs to be a bit more specific about this for one of the theories that we developed. But basically, you can pick whatever you want, right? So if you're in Germany, you could use a German stock market index. If you're in the US, choose a US stock market index, right? You can choose any kind of indicator that you want. Now, what we want to measure is basically how are shares performing now relatively to the stock market. So let's look at the electric car manufacturer. The electric car manufacturer is down when the stock market is down. It's up when the stock market is up, right? So if my left hand is the car producer, my right hand is the stock market. They're moving in the same fashion, right? They're both high at the same time or low at the same time.